In this video, let's just apply the same principles that we used to get the output of the inverting amplifier and see what the output of this circuit is going to be. Okay, so let's start by applying our first characteristic of the ideal op amp. And the first characteristic basically implies, the first rule tells us that if V output is going to be finite, we'll have the difference of the voltages between the two inputs is going to be zero. So the voltage applied here is V in. So the voltage at this point is also going to be V in. Okay, so now we also know that the current that is going into the op amp is going to be zero. That's the second characteristic of the ideal op amp. So IR1 is basically going to completely flow through resistance R2, and therefore IR1 will be equal to IR2. Now what's the equation for IR1? Now take a look at the voltage here. It's going to be zero because it's connected to the ground. The voltage here is V in. So IR1 is equal to 0 minus V in over R1. What is IR2 going to be? The voltage here is V in. The voltage here is, you can take a look, the voltage here is VO. So we have V in minus VO over R2, right? So now let's just apply the condition IR1 equal to IR2, and what do we get? We get 0 minus V in over R1 equal to V in minus VO over R2. This means that V in 1 over R1 plus 1 over R2 equal to VO over R2. And so if we resolve this equation, what do we get? We get V in equal to 1 plus R2 over R1 times V in. I'm sorry, this is supposed to be V out. So what we get is V out equal to 1 plus R2 over R1 times V in. So you can see that in this particular circuit, our gain, what's our gain? So our gain is this quantity here, which is 1 plus R2 over R1. And our gain is always greater than 1, right? It's always positive, and therefore we call this circuit a non-inverting amplifier. Okay, now this non-inverting amplifier can give you a positive gain, which we were not able to get with the inverting amplifier, and also we always get a gain greater than 1. We cannot get a gain less than 1. So a non-inverting amplifier is unable to reduce the amplitude of the signal. It will always increase it. It will have a gain of which is greater than 1, or actually it is greater than equal to 1, because it will be equal to 1 if R2 is equal to 0.